So, welcome everybody to my channel of AG Math, The Way of Life. We discussed in our previous session regarding binary operations. What is a binary operation and how it works on different types of sets like natural numbers, real numbers, or a given particular selected type of set A. And we also understood how the symbols are used and what is the interpretation of a binary operation in our mathematical uh, subjects. Okay. Today, as I told you that we will be discussing certain topics. So we will discuss about the operation table. We will try to cover commutative of binary operation and associativity of binary operation. So to understand the binary operation, I again revise with these two examples. Suppose a problem is given that A binary B, we read like this, A binary B is equal to 2A plus B minus AB for A and B belonging to Q, a rational number. Q is the rational number denotation. Then we have to find 3 binary 4. What is the result of 3 binary 4 if we follow the binary operation of this? Right. Now here when you look at the binary operation given, A binary B means the first element is coming two times, then added to second element single, then subtraction of the product of the two elements. So accordingly, we will treat 3 and 4 as the first element and the second element and write the expression of the right hand side here as my solution. Right hand side, I will replace A and B with 3 and 4. So what is now coming up is 2 into 3 because A is 3 plus B value is 4, then multiplication of 3 and 4. And when you simplify this small arithmetic equation, you get 6 plus 4 minus 12 and that answer is minus 2. Second problem we discussed here is if A binary B is given as A square plus B square and A, B are belonging to the natural number. Here the A, B elements have come from the set of natural number. Natural number you all understand that it is 1, 2, 3, 4 up to infinity. And second binary operation is given here as A binary B. As I told you earlier in the previous session that the symbol for binary may be asterisk, may be a small zero or maybe something like a B here and an inverted B here. So these are all referring to the binary operation. Now A small o b, that is also said that A binary B is equal to A cross B, which is the product, and all these A B are coming from the set of natural number. So taking for the first problem, find the first part is 2 binary 1 whole binary 2, means the result of this binary you have to operate on the binary 2. So the result for 2 star 1 is to be used like this, which is given as a square plus b square. So a square is 2 square plus 1 square and then operated on 2. So we get 5 operated on 2 and operation 2 for the small o operation is a multiplication. So 5 and 2 gets multiplied and not added or not squared and added. So it will give us an answer as 10. Now the second part for this type of problem was 302, that means 3 binary 2 whole binary 4. So 3 binary 2, we will apply this formula which is given here. We treat it as a formula or a type of relation and we use it 3 into 2, then binary 4. So 3 into 2 result is 6, binary 4. Now 6 binary 4 has to be used like this. That is A binary, that is asterisk B, relationship A square plus B square. The same thing we will use here. So this is A, this is B, 6 is becoming A square, 4 is the B square, and we get the result as 52. Now, as I told you that I will talk about the operation table. Sometimes the binary operation we can write in the form of tables. And I have given you one workout examples here. A binary B gives maximum of A, B. Maximum is also a binary operation because between two of them, a maximum has to happen. If two things are different, one will be bigger than the other, and the bigger one is called the maximum. Similarly, A binary B gives minimum AB. That means out of this two, there will be a minimum value as well. So let us take, for example, that I have taken 1, 2, 3 as the numbers, natural numbers for writing this table. So in writing the table, we normally design the table like this. Use the binary symbol at the left hand top corner and then select how many elements you are trying to compare for maximum and minimum. A and B, you have to select pairs. That means if you have selected three numbers of A, three numbers of B will also be selected. So I write, suppose A is here and B elements I am writing here. Now, what is the relation of 1 and 1? What is the maximum for 1 and 1? That value we will write in the first uh, block here. So the first block maximum value will come as 1. Out of 1 and 2, what is the maximum? Answer is 2. Out of 1 and 3, the answer is 3. Likewise, the second row, between 2 and 1, what is the maximum? 2 is the maximum. Between 2 and 2, 2 itself is the maximum. Between 2 and 3, 3 is the maximum. When I look at 3 and 1, the combination gives me 3 as the highest or maximum number. Similarly, for 3 and 2, I get 3, and for 3 and 3 is also 3. So you look here, this is the relationship. So this is called the tabular form. I leave the other part, A minimum B or A binary B for minimum A and B. We can construct the table like this, only change the symbol for the binary to the inverted V and then compare which is minimum. Okay. Then I discussed today what is the commutativity. How we talk about the commutativity. Commutativity definition is a binary function on the set X is called commutative if A binary B is equal to B binary A. We write the definition. A binary function is said to be commutative if uh, A binary B is equal to B binary A in a given set X. This is the definition for commutativity. Now, for example, if I take one problem like A binary B is equal to A plus 2B. Problem for discussion is A binary B is equal to, it is A plus 2B. We have to verify whether it is a binary operation. For example, let us assume that A is equal to 3 and B is equal to 4. We have taken any number by assumption. Now, following this binary operation condition given, if I write A binary B, it will be simply A plus 2B. The first element is 3 and 2 times the second element is 8. So I get the answer as 11. And for binary commutative property, it has to be same as B binary A. So when I write the B binary A, I write 4 first, then I add 2 times the 8. So that is 6 and it becomes 10. Now you see this 11 is not equal to 10. So this is not a binary commutativity. because commutative property is not fulfilled. So it is a binary operation, but commutative property is not fulfilled. Similarly, if you look at it, what is the addition? Addition operator for this a plus b is equal to 3 plus 4, which is 7. And for b plus a is also 7. So addition is a binary commutative property. If I say subtraction and I write a minus b, then its value is minus 1. But again, b minus a, when I write, what is the value? It is 4 minus 3 is plus 1. Now this minus 1 and plus 1 are not equal. So commutativity is not followed here. It is followed here. Now if you take the operator as multiplication, I write a into b, that will be definitely equal to b into a. So it is, yes, commutative property follows here. If you look at the division, normal division operation in arithmetic, so if I divide a by b, will it be equal to b by a? I don't think, because a by b is 3 over 4 and here it is 4 over 3, which is not equal. So it is not. Likewise, we check whether commutativity is valid for certain binary operations given. Now, how we check the associativity? You know what is associativity? Associativity can be only between three terms. It is not possible to define associativity in two terms. This we all know. So associativity of binary operation is said to be if A has binary B, binary C, if A binary B and whole binary C is equal to A binary of B binary C. If this is happening, then we can say it is a associative property of a binary. For example, if we take a problem like A binary B is given as A plus 2B, right? And we have, suppose, three elements. Let A is equal to 2, B is equal to 3, and C is a 4. So we have assumed three elements as ABC. Now left hand side is here. Left hand side is A binary B whole binary C. Correct. And when I write what is A binary B, as per this, I have to write A plus 2B and then binary C. Right. And from A plus 2B, what value I get? If I have assumed A and B like this, then I get A is 2 plus 6 and binary of C. So it is 8 binary C. Right. Now if I write 8 binary C and I again apply this rule, then first element is 8 plus 2 times of C. 2 times of C is 2 into 4. So I get 8 plus 8 is equal to 16. This is the left hand side. When I look at the right hand side, what is the right hand side? We will work out the same way. A binary, B binary, C. A binary whole of B binary C. And first of all, we work out for B binary C. B binary C is equal to, B is 3 and C is 4. So we write 3 plus 2 times of 4 as per this. So it becomes 8 and 3 is 11. Now we get A binary 11. Again, using this relation, what we have to write is A is single 2 plus 2 times 11, which is 2 plus 22, and answer is 24. So here I am getting an answer of 24, and in the left hand side I am getting an answer for 16. So we definitely find that left hand side is not equal to right hand side. For this type of binary, associativity is not applicable. It is not conforming to associativeness. But if you look at the natural numbers, it will definitely work. If I say check associativity for n as frequent to n, then it will definitely work. So it is third part. It will definitely work. When you use any three numbers, left hand side and right hand side products will be always matching. So let us stop it here today. And if you like this video, please click on the icon and subscribe as well, so as you get the intimation about the next upcoming videos. And I look forward to your following this series, because it's very important, as I told you earlier even, that for any advanced studies of computers or IT uh, subjects, you need to know what is binary and how the operations go on. Thank you very much for your valuable time. See you again.